Windows PowerShell's scripting language. In this nugget, we're going to dive into the constructs that are considered to be the basis of Windows PowerShell's scripting capabilities. We'll start with two logical constructs, if and switch, which are designed to allow your scripts to make decisions and react differently depending on the situation. We'll then look at two looping constructs, for and while, which are designed to allow your scripts to perform repetitive tasks under your control. We'll look at the foreach enumeration construct, which allows you to go through individual objects in a collection and work with each object one at a time. And then we'll look at just a few miscellaneous scripting language elements to sort of wrap things up. So let's begin with the if construct. And I'm going to do all of this in an editor rather than in the shell, because many of these constructs have different variations. So this will be a good way to sort of lay them out and look at some of the different things they can do. Let's start by just creating a variable and putting a value into it. The if construct is designed to execute some logical comparison, and if that comparison is true, then to execute some code that you specify. We begin with the keyword if. The condition is in parentheses. So let's just say if var is greater than 100. Now if that's true, in curly braces, we specify the code that we want to execute. Right host is greater than 100. Whatever goes in these parentheses simply has to result in true or false. Because all of the comparison operators always produce a true or a false value, that's what you'll usually see in here. So let's just go ahead and run this, and we can see that there was no output. And that's because var equals 100, but it is not greater than 100. So let's change the value to 200 and run the script again. Now var was greater than 100, and so our conditional code executed, and we got that output. Again, what goes in these parentheses simply has to result in true or false. Now in this particular instance, we're getting true or false through a comparison. But let's say we put the special PowerShell true value into var. We don't actually need to compare var to anything to see if it's true or not. Because var is going to contain true or false, just putting var in here will bring the value true or false into these parentheses, and that's all it needs to see. So if we run this, our condition was true, and so we got our output. If we change this to false, run it again, this time we don't get any output because this wasn't true. So let's look at another way that you can use this construct. We're going to switch back to putting a number in var, and we're going to change this comparison var greater than 100. If that's not the only comparison you need to run, you can use the else if keyword and provide another comparison or another condition. If var is less than 100, then we'll execute this code. Finally, you might want to provide some code that runs no matter what, and you do that with the else keyword. It doesn't get any kind of condition. It just gets the code that you want to execute. So when we run this, we should find that var is not greater than 100, nor is it less than 100. So the expectation is that this is the default will be displayed. Whenever you're writing any kind of script, it's always good to have an expectation for what will happen. That way, if it doesn't happen, you can sort of figure out where the problem is more easily. And so that's the output we got. This is the default. You can have as many else if sections as you want. For example, after this condition, I'll put another else if var is greater than 200. Let's look what happens if I set the value to 300. There's a couple of different expectations you might have. var is definitely greater than 100, so you might expect is greater than 100 to be displayed. It's not less than 100, so we shouldn't expect this to be displayed. Var is greater than 200, so you might expect this to be displayed as well. Let's run it and see what happens. It displayed is greater than 100. That's because the if construct only executes the first matching condition. Once this executes, the rest of these conditions aren't even evaluated. So this will never actually execute, because if this is true, then this must also be true, and so this is the first one that will execute, and nothing else will execute. So that's something to remember about the if construct, is that only the first matching condition will execute. Next up is the switch construct. This is designed to take a single variable and compare it to multiple different possible conditions. So we'll start by, this time I'm going to put a string into the variable var, the keyword switch. In parentheses, we're not putting a full comparison. We're just telling it what variable we want to look at, and then enclosing the entire construct in curly braces. Now, within this construct, we're going to put all the different conditions that we want to check for. For example, we want to check to see if var contains hello. And if it does, we want to execute this code. Now we want to check and see if it contains a lowercase hello. And if it does, we want to execute this code. Finally, let's see if wildcards work. Let's just check for LL in there, and if it exists, we'll execute that code. Now, if none of those conditions have been true, let's provide a default block and execute that code. So let's see what happens when we run this. The first and the second blocks both ran. That's because the switch construct will evaluate each possible condition, and it will execute all of them that match. You can see that hello and hello were both treated the same, in keeping with PowerShell's normal mode of doing case-insensitive string comparisons. So let's put one last line in this script just to create a little separator for our output, and make one change. The switch construct actually supports a few different parameters, one of which is case sensitive. Now let's run it again, and this time we only got first as our output. That's because once it became a case sensitive comparison, the lowercase hello did not match the one with the uppercase H. Okay, let's change this parameter once more to be wildcard and run it again. This time first, second, and third ran. So this matched because it's case insensitive again, and this matched because now it's accepting wildcards. You can provide more than one parameter. We'll put case sensitive back in here. Ask for another run through. This time first and third both matched. That's because this is an exact match, and these two characters are found within the string, and they're found in a case-sensitive way. So what if you don't want it to execute every single one that actually matches? Well, no problem. Let's take out case-sensitive. That'll give us the most possible matches, but we're going to add a keyword to each one of these blocks called break. Break simply exits the entire switch construct, preventing any further matches from occurring. So this time when we run it, we only get first. That's because Windows PowerShell went through, matched this, executed that, executed the break, and then left the switch construct. It was no longer in the switch construct, so it never even tried to make matches with anything else. Now finally, let's see the default block in action by specifying something that we know won't match any of our first three conditions. This time when we run it, we only get default as our output. That's because this did not match, that did not match, and that did not match. Provided nothing else matches, the default block will execute. So those are the two logical constructs, if and switch. Now let's move on to the looping constructs. And the first one I'm going to show you is called while. So to kick this off, let's set a variable var equal to 100, and then the while keyword, followed by a condition in parentheses, var greater than 1. Then in curly braces, the code that I want to repeat, so long as this condition is true. So long as that condition is true, I want to take whatever's in var, subtract 1, and put the result back into var. And actually, let me show you a little shortcut way to do this on a PowerShell comment. The hash mark starts a comment line. PowerShell will ignore the rest of this line. So another way to do that mathematical calculation is var minus minus. That'll automatically subtract 1. Another way to do it would have been var minus equals 1. That will take whatever's in var, subtract 1, and put the result back in var. So a couple different ways that you could do that. We'll wrap this up by just writing the contents of var. Now this time I'm going to run this in an external shell. And you can see that we started at 99 and went down to 1. So the first time through the loop, PowerShell hit this and said, okay, we're only going to do this if var is greater than 1. Well, it's greater than 100, so we'll go ahead and do it. We're subtracting 1, so now var contains 99. So we write 99 and come back up here. Is var greater than 1? Yes, it is. So we'll subtract 1, display the result. And that continues. Now at some point we get down here and display 1, loop again. Is var greater than 1? No, var is not greater than 1. It's equal to 1, and so that's when the loop finally exits. It's important to note that this loop will only execute once, provided the initial condition is true to begin with. So let's change var equal to -10. Now var is no longer greater than 1 to begin with, so my expectation is that none of this code will ever execute. And that's exactly what happens. Now let's sort of turn this on its head a little bit. I'm going to replace the keyword do, while, with the keyword do. I'm going to move the condition down to the end and say loop while. So look at how this changes the logic. There's no comparison here, so we're always going to drop into the loop. We'll subtract 1, which means var now contains -11. We should display -11. And we're only going to continue while var is greater than 1. Well, it's not greater than 1, so hopefully that means we won't go any further. We displayed -1 and didn't go any further. So by arranging the logic in this fashion, we can ensure that the loop always executes at least one time, but that it only continues executing if this condition is true. Now you can actually reverse that logic by changing the while keyword to until. Now we're going to come into the loop, subtract 1, write host, the result, and we're going to continue until var is greater than 1. If we do the math for a second, you might realize that we're always subtracting from var. var will never be greater than 1. That would result in what's called an infinite loop. Let's try it. And this will go on forever now, until we hit the magic Control-C to break it. So that's kind of a logic error. You certainly don't want that in a script for real. Maybe the way to change this is to add 1 to var. Now the equivalent now would be var++ or var plus equals 1. So var is -10 to begin with. We're going to be adding 1, and we're going to stop as soon as it's greater than 1. This time it does end, as soon as it becomes greater than 1. So this is a great way to repeat repetitive tasks over and over and over. There's one more looping construct that we can take a look at, and that's for. So the way to do this is to start with the keyword for, and then in parentheses, specify a starting condition, var equals 0. Then a semicolon, and a condition that will be evaluated each time the loop executes. The loop will only continue executing so long as this condition is true, var less than 100, semicolon. And then finally an action which will be taken each time the loop is executed. Ideally, this needs to eventually result in this condition being false so that the loop eventually exits. So we'll say var plus plus. Add 1 to whatever's in var. After the condition, just use curly braces to contain the code that you want to go in here. Right host var. So when we run this, we counted from 0 to 99. Now, var is infinitely flexible here. We can do anything we want to this variable. For that matter, the for conditions are pretty flexible too. For example, let's change var equal to 100. We'll only continue counting while it's greater than 0. And each time through, we're going to subtract 2. So this time when we run it, we count backwards from 100 only the even numbers. So the for construct offers a good amount of flexibility for looping through numbers sort of in sequence. You're primarily going to use this if you have a task that you know you need to complete for a specified number of times. It's certainly possible to rewrite this as a normal do loop. For example, here's my starting condition, var equals 100, do, and then only continue repeating while var is greater than 0. And then somewhere in the loop itself, I have to make sure I'm modifying the contents of var, so var plus equals 2. This is pretty much the same thing, just done a little bit differently. You can see that this syntax with the for construct is a little bit more concise. So if all you need to do is repeat something a specified number of times, sometimes that's a little bit easier to read, which means in the long term it's going to be easier to maintain. Now there is one more type of looping construct we can look at, and that's for each. For each is designed to take a collection of objects and go through them one at a time. This is really similar to the foreach-object commandlet. For example, with foreach-object, we can get service, pipe it to foreach-object, and then tell it for each object we want to take the name and display it in all uppercase letters. So if we run this, there's all the service names in uppercase letters. We got all the services, piped them one at a time to foreach-object. This script block executed once for each one, and each time $underbar was assigned one of the service objects. We took its name property and executed the toUpper method. In a scripting language, you might see this done something like this. Services equals get service. So we're going to get all the services and put them into the services variable. For each service in services, we will write host service dot name dot toUpper. This is functionally equivalent. We're getting all of the services and putting them into this variable. So that's a collection of objects. For each accepts its operating conditions in parentheses. We're saying for each service in that collection, each time through the loop, the next service will be taken out of the collection variable and put into this variable that we specified. We could have named this anything. We could name it X if we want to. Just need to make sure we're consistent about it. Once we've got a single service in X, we can do something with it, such as converting its name to uppercase. So I'm going to delete this and just run this script, and we get exactly the same results. You may find out that on the Windows PowerShell command line, for each is actually an alias to foreach-object. This is where things can get a little bit confusing. Let's get the alias for each. You can see that there is an alias for each, and its definition is foreach-object. So if I can do this, get service, pipe to foreach-object, and then in parentheses, put what I want, or in curly braces, put what I want to happen. So if that works, then I should be able to replace both of these commandlets with aliases, such as GSV and foreach. And that does work. What you cannot do, though, is use this in syntax with the commandlet. In other words, I can't say can't say this. That doesn't work here in the pipeline. So there's actually the alias for each, and then there's the scripting keyword for each, and they have different syntax, and it's confusing. And personally, I think it was a bad idea for the PowerShell team to do that because it is confusing. Here's how I resolve that confusion. I never use the alias for each on the command line. If I want to use for each on the command line like this, let me take away this code that won't work. I use the %sign alias, which has the same effect. You can't do that here though. If you do for each object here, I will get an error message when I run this, because for each object does not want to see this in syntax. So that's just something that you kind of have to get a little bit used to. So those are all of the looping constructs: for, do, while, until, and for each. All right, let's do a little scripting language inventory for Windows PowerShell here. We started by looking at the if keyword. We then went on to look at switch. We looked at the do, while, and until constructs. We also looked at for and for each. That's only 1, 2, 3, 4, 5, 6, 7 keywords. There's only a few more. Technically, we also looked at break, which will exit any construct except an if construct. There's also trap, and there's also throw, and there's a keyword called return, and there's a keyword called function. Now we'll be looking at function in the next nugget. We've already looked at break. We will be looking at trap and throw in a later nugget, and we'll also be looking at return in a later nugget. That's 7, 8, 9, 10, 11, 12 keywords total. That's the entire scripting language for Windows PowerShell. There it is, all on one whiteboard for you. So if you thought that Windows PowerShell was going to be a really difficult scripting language along the lines of VBScript, which has well over 100 intrinsic keywords, hopefully this gives you a little bit of confidence. The pickiest you can really get here is to say that the else if and else keywords have to be counted, and that the default keyword that goes with switch has to be counted. And if that case, you still only get yourself up to 15 keywords. Nice, simple language. In this nugget, we looked at the elements of Windows PowerShell's scripting language. We started off with logical constructs, including the if construct and the switch construct, which allow your scripts to make decisions. We looked at two looping constructs, including the for construct and the while construct, and of course its many variations, which allow your scripts to perform repetitive tasks. We looked at the enumeration construct for each, and remember that this is not quite a substitute for the foreach-object commandlet. It uses a slightly different syntax, and within a script allows you to go through a collection of objects one at a time. We wrapped up with a few miscellaneous scripting language elements. I hope this has been informative for you, and I'd like to thank you for viewing.